We're live. Oh my gosh, I am so excited. I don't know if you're excited. This is Math 60. This is intermediate algebra. This is 6.7, baby. And this is almost the end of chapter 6. This is so exciting. 3 pages stand between us and greatness. Or chapter 7. Which we'll see whether you like chapter 7 or not. Well, it's a thing. But so let's go ahead and let's talk about the difference between an expression and an equation. Woohoo! Sorry. So let's talk about a difference between an expression and an equation. An expression is something that doesn't have an equal sign in it. For example, if I just have the number 3/4, that is a rational expression. Now, the only way to balance 3/4 is if I want to, I could multiply top and bottom by 2, for example. I'm allowed to do that. Now, tell me about an equation. Well, an equation would be x equals 3/4. If I have an equal sign, I don't have to worry about top and bottom. When I have an equal sign, I'm allowed to multiply both sides, left and right, by 4 to clear fractions. Does that make sense? So this is a big distinction, big difference. If you just have an expression, you have to balance top to bottom. With an equation, there's the balance is left and right. See that distinction? So if we do have an equals, we're allowed to go left and right. If we don't have an equals, we have to go top and bottom. So remember that. Once you've done 6.7, if you go back to the other parts of chapter 6, your brain can get a little bit confused. So do each section separately and really think about, why am I approaching this the way I'm approaching this? However, now's the time. We're going to have some equations. This is very exciting. Okay. Woo, that was so exciting that the whole table moved. Woohoo! Let's hear it for us. Problem number 1. I'm going to ask you to solve and check. 2/3 minus 1 over y equals 5/6. What is different about this? Oh, that's why the table moved. Yeah, I don't really think, sorry about the light. I don't really think that Papua New Guinea was the earthquake that happened there just now actually moved the table, but maybe it's possible. It was a 6.3. That's pretty big. I hope they're okay. Ooh. Okay, so hopefully in the future that was not a terrible thing to happen in Papua New Guinea, but I'm hoping that the people there are all okay. So back over here, we're going to solve and check. And the reason that this is slightly different is that y is in the denominator. Notice that y is underneath. That is what makes this a complicated problem. Normally, we'd have a bunch of fractions and the y would be on top and there'd be no big deal, except it would be fractions. So first thing, we note any restrictions on variables. Remember what that means? That means 1 over y can't be what? 0. You're right. So we say y is not equal to 0. And we say that right up front. We say, do not let y equal 0. And it's going to sound weird, but it is possible we will forget that. So I'm going to put a box around it. Okay, we do that first. Woohoo. Next up, let's clear fractions using the LCD. Okay, what are my denominators? Denominators are 3y and 6. I need the most or a common multiple for all of them. 3 goes into 6. 6 goes into 6. My LCD is as simple as just 6y. That's kind of cool. Now, if you just multiply them together, you get 18y. Will 18y work? Totally. It will totally work. So it's up to you whether you want to use the least common denominator or just one of the other ones. Now, who gets a 6y? Everybody, let's Oprah this thing. So 6y goes to the 2/3. 6y goes to the 1 over y. And 6y goes to the 5/6. So far, so good. Okay. Now, the 6y times the 2/3. The 3 cancels with the 6y and leaves 2y. So far, so good. Here, the y cancels with the 6y and leaves a 6. And here, the 6 cancels with the 6y and leaves a y. So I think I've got 2y times 2 minus 6 times 1 equals y times 5. Or in other words, 4y minus 6 equals 5y. Okay. Why is this better? Well, I think this is a lot easier to solve than this one. I don't know if you guys agree. I mean, this is a lot of work, and it could be that you're looking at all this going, oh, wow, math is not what I want to do with my time when I figure out what it is I want to do with my time. And I totally understand that. But if you do end up having to do math in your job or in your life, I would still claim this is a lot better than that one. So let's keep going. Let's see. There are more happy y's over there. So I'm going to move the y's over onto the right-hand side by subtracting 4y from both sides. And I get -6 equals y. Y equals -6. Okay. Now, once you get the answer down here, you go back up to the top and you go, wait, what was y never allowed? Don't let y be 0. Okay, thank goodness. No, y is not 0. Y has to be -6. Oh, we found a bug. Yes, it is getting dark outside, so we've got a problem because now the bugs are all going to want to come to my little light. They love math videos. That's the truth of it. All insects love videos about math. It's a thing. Okay, so here we go. Let's check. And in my usual ways, I have not left any room for the check, just for fun. Let's see if we can fit it in anyway. So let's see, I've got 2/3 minus 1 over, and it's supposed to be y down there, so there's a -6 there, equals question mark 5/6. So I've got 2/3 plus 1/6 here. That becomes a minus, and minus becomes a plus. I've got to write the 2/3 in terms of 6. This is 6, so 2 times 2 is 4/6 plus 1/6 equals 5/6. Look at that, yay! Yay, it checks, yay. So our answer is just y equals -6. And we don't need to say y does not equal 0, because in our final answer, we say y equals -6. So of course it doesn't equal 0. So there's no confusion there. Kind of woohoo. Okay, you want to try another one? I mean, do you have any choice? I'm going to keep going. If you scream really loudly at the monitor, maybe I'll hear you. Not. Okay, so. Dun, dun, dun. I mean, these problems just keep coming. I got to warn you, this is a big part of math, is doing equations where x exists in the denominator. So, yay, math. Okay, so first off, restrictions. I look through, I see there's a 3x in the denominator, which means I can't let x equal 0. 3x can't equal 0, right? I don't want that whole denominator to equal 0. Here's handy dandy yellow highlighter. I don't want that denominator to equal 0. So when does it equal 0? If 3x equals 0, then that means divide by 3, x equals 0. This is what they call bad. So let's not let x equal 0. Okay, LCD. I've got the denominators. This is a little more complicated than the previous one, so I'm going to write them out. There are my denominators. Uh, 15 is 5 times 3. 3x is 3x. 5 is just 5. Okay, the most. LCD. So I've only got 1 5, and everybody except for this one doesn't even have 1 5. But the most number of 5s I have is 1. The most number of 3s I have is 1. The most number of X's I have is 1. So it's just 15x. It wasn't that complicated. It looked bad, but it wasn't. Okay, once I've got my LCD, everybody gets it. So 15x over 1 times 12 over 15 minus 15x over 1 times 1 over 3x equals 15x over 1 times 4/5. So again, let me pull this down so you can see the original problem. So each one of the terms in the original problem gets its own 15x over 1. I'm not sure if the yellow comes across quite as well as the blue. I'll try to remember the blue for making open boxes. Okay, shall we? This one's going to be a little bit more gruesome. So as I usually do, I'm going to go ahead and rewrite it. Notice that at no time does my arm actually fall off my body. It feels like it will. Honestly, right now, as many of these videos as I've been making, my arm, my whole hand, everything is on fire. My carpal tunnel is about the size. It's that big. Oh, you can't see. It's that big. It's that little space in between all my fingers. That's how big my carpal tunnel is. And so everything is swollen and aching, and yet still I am able to write out all my notes. Even as an aged 400-year-old person, I can do this, so you can do it too. Okay, so let's see. I'm going to cancel the 15. That leaves x there. I'm going to cancel the 3x with the 15x, and that leaves 5. Cancel the 5 with the 15x, and that leaves 3x. Okay, it's kind of a mess, so I'm going to rewrite x times 12 minus 5 times 1 equals 3x times 4. So take a good look at that. See if you see where I'm getting all these from. In fact, I don't even have to wait. You can always pause the video. That's the great thing about videos. So I can pretend like I'm paused, like, but my finger is wiggling over here, so never mind. Okay, 12x minus 5 equals 12x. Ooh. That's exciting. That is very, very exciting. What happens when I subtract 12x from both sides? I didn't see this one coming. I wrote this long enough ago. I didn't see it coming. Dun, dun, dun. Okay, so tell me. I know, your lizard brain is like panicking. Ah, I need a lizard here, this will be let's just say this is a lizard, even though it's a spider. Ah, it's all broken. Ah, the mouth doesn't work. Yeah, okay. Calm down your lizard brain. Tell it it's all going to be fine. We'll find it a nice warm rock. Everything will be good. What happened here is I ended up with the same number of x's on both sides. And when I subtracted x's to move them, they just vanished, which means that this problem is either always true or always false. So in other words, the x's don't even matter. This is something that is either always true, so it's a tautology. It is true no matter what, or else it is false, which means there's nothing you can do. No number you could plug in for x is going to make it true. So -5 equals 0. You tell me, is that true or false? This is false. This is great. This is the best thing ever, except for math. For math, it's very sad. But for a student, this is great, because if it's false, there's no solution. Why is this so great? Well, if there's no solution, there's no check, and we're done. Bam. So we've got one more. I'll make one more video. There's one more problem I want to show you. Another thing that can happen. It's very, very exciting. Wait till you see. I know. I'm very excited to show you. And then we are done with chapter 6, which is a little bit of a lie, but for now, we're done with chapter 6. Woohoo!